to talk about our project, which is called Sole.jl, and now you can use it for symbolic learning and rule extraction. So first of all, if you want to download the slides, here you find the QR code. So I'll leave it there for a couple of seconds. And yeah, here you can see we brought the whole squad today, but actually there's many more of us. We come from the Department of Mathematics and Computer Science in Ferrara, in Italy. And specifically from this small lab, which is born in this department, where you can find PhD students, but nowadays also master students and bachelor students that start to do their internships and then keep working with us. And this lab is called Applied Computational Logic and Artificial Intelligence. And what we do most of the time is symbolic learning, which is a specific kind of machine learning based on logic, so that you can have interpretable models. And most famous examples are, of course, rule-based models or decision trees, random forest. But what we wanted to do was to generalize these famous algorithms to cases where you couldn't use them yet. That's why you can read in red the word modal in the 3 of those packages, because we leverage modal logics to not only treat tabular data, but also time series, images, audio data, still using something which is interpretable because it's based on logic. And you can find foundational models like SoleLogics to work with logics, of course, but also a package to work with datasets and translate them in the logic counterpart, to define your models, and a lot of stuff that you can also do after you train some models. That's why you can find a package like one of my favorites, SoleReasoner. We won't talk about it today, but I invite you to check it out, and SolePostHoc to get better models, miniature models, and those kind of stuff. And I want to invite all of you, I encourage you to try to download those packages and try them out for yourself. They are pretty stable, they are well tested, and they are well documented, and they are all registered. So we are open to contribution, and we really like to have some help with those some packages, especially testing them. For those of you who were at JuliaCon in the last couple of years, you may already have heard about Sole, because Joe, who is in the audience today, already spoke about it. And today we are going to continue bringing you what are the new developments in our framework. Specifically, we will focus on model association rules and on SolePostHoc. And we will also have a small surprise at the end. So now I leave the floor to the younger students. And yeah, the floor is yours. Wow.
Thank you very much, Alberto. So let's start with modal association rules package. Okay, so let's say we have a set of facts that essentially are Boolean conditions. They can be true or false, okay? And we are interested in these facts. We call them items in the jargon. And we want to arrange such items into patterns that are frequently occur in the data, okay? Then, after finding them, we want to also combine them into rules. And the ultimate goal of this combinatory exercise is to describe non-trivial aspects in data, especially in relational data. And we follow this general pipeline in the package. This is the workflow we follow. The first step is called logiset loading or logiset creation. The point is, okay, we have a classic dataset, maybe a dataset of temporal data. We have this time series, these signals here, encoding gesture of an operator, okay? Maybe this encodes the y coordinate of the right hand of the operator, okay? And we want to let some relations emerge from this data. We do not want to flatten it, okay? So what we can do is we can split, we can dissect the signal into many subsequences up to a certain granularity level, okay? And we call all such subsequence, we obtain worlds, okay? And then we can explicit the relations among worlds, obtaining what we call a logiset. That it can be shaped like this, okay? So we have all the subsequences here. Now we associate each subsequence or world in the jargon with a letter of the alphabet, okay? And now we can reduce the problem of mining a set of frequent facts on the logiset to the problem of, performing a graph data mining task, okay? So we can walk in the logiset looking for particular relations. So how we define the items? This is a sort of pseudocode, but it's quite similar to what we would write in Julia. So we have a certain fact. Here we are calculating a distance, such as the Euclidean normalized distance between a certain world and a signal we have. And we are enriching each fact with a specific relation, okay? So we can say that the fact has to be evaluated here on the current world I'm considering, or in a world that is in an after relation with the current one, and we can also concatenate multiple relations, okay? And we have measures to establish whether a set of facts is interesting to us or not. There is a huge literature about these measures of interestingness, but we can just go on here. And the idea, I'll go really fast on this slide, really, but the idea is that we can arrange complex patterns saying, well, on the given world, P is true, and there's also a world in an after relation where another signal in green is similar to the blue one, but these green signals begins with something that is similar to the purple signal. We can arrange these complex statements, okay? And we follow a search strategy, of course. It can be based on a breadth first search or a depth first search, on the search space of all the possible frequent set of items. There are also more complex approaches, mixing BFS and DFS, or maybe approaches that are based on compression algorithms, okay? And after all these definitions we do while using the package, now we just need to call a function. You can see it here below. It's called mine, to find all the set of interesting facts. And then we can also call generate rules to rearrange these sets, forming complex rules. Okay, this is the idea. At the end of the presentation, we'll see a brief, more concrete example, but this is all for me. So what are we gonna do with these rules? What is the post-processing we can do? Well, Marco, it's your turn.
Thank you, Mauro. Hi, everyone. I'm Marco Perrotta, and today I talk about SolePostHoc. In fact, many methods exist to extract a logical rule from learning model or into general from models. However, there is currently none unfilled into framework, okay? It's not present all state of art in one unique package. That's exactly what this package aims to provide. SolePostHoc integrates a wide range of algorithms for knowledge extraction, including surrogate tree. With this, we can start from model and generate one tree, decision tree. Knowledge distillation, with this, we can create one new model and can extract the main feature from the starting model. And rule extraction, we can extract the rule and obtain the minimal rule in different logic. In this case, we have surrogate tree. For example, we have Trepan, Refne, Beatrice. For knowledge distillation, we propose rule così, the state of art of knowledge distillation algorithm. And rule extraction, we propose Lumen and Intrees. This package primarily propose is to provide with uniform interface and one uniform output for take one comparison and with coherent and intuitive user experience. Now we can start with one example. We can start to use one dataset, the most famous dataset in the literature, Iris, and with this we can start to learn one model and extract rule. We have two primary methods for do it. With first approach, we can start and use the specific call function, okay, for example, Lumen or Intrees. The difference in this case is the difference for call function and the output. For example, with Lumen we take one decision set, with Intrees we take one decision list, and or with one surrogate tree, for example, algorithm, for example, Trepan or Refne, we take one surrogate tree, one decision list, one decision tree. In this case, we can use the second approach. With the second approach, we can use one only function call, model extract rule, and with this, with one extractor, we can obtain one decision set. The key advance of the second approach is that it only executes the original algorithm, it's not only executes the original algorithm, but we also convert the output in one decision set. For repeat, we can start with the one input model, we can do one extract method, we can choose one extract method, and obtain one classical output. If we choose one second approach, we can obtain one decision set. The decision set is a vector of propositional rule, okay, in the DNF formula, where we have one rule from any label, okay, for classifier model, and this is all for SolePostHoc, and I leave the floor for the little surprise.
Hi, my name is Riccardo, and sorry for my English. I will introduce you to SoleXplorer. SoleXplorer is nothing but a machine learning framework, well, with some highlights. And this comes from our experience in making experiments with machine learning. And we try to overcome all the tedious processing that we find in making experiments. One thing that we noted is that a lot of, especially in dataset preparation for a machine learning experiment, there are a lot of things that can be automated. And why not to do that? Because we know we have a lot of things to do and to think when we do experiments, even because, you know, an experiment is not only one experiment, but you have to loop experiments until you find good hyperparameters. So everything that can be automated for our point of view is very good. And we decide to make everything smooth. Every parameter is defaulted. So you can start with a simple experiment and then add more hyperparameters or more configurations. It's logic based because one thing that SoleXplorer does is to include rule extraction and rule associations. And this must be done only translating from a traditional machine learning language to a logic-based language. is time series analysis ready. And this is very important for me because I'm an audio technician and I've done a lot of experiments in audio. Audio are nothing but vectors or of numbers. And during experimentations, I noticed that if I miss, if I translate that information in punctual data sets, I lose the time information. And this is, for some experimentations, really important. So this is really important for me, time series analysis. And then one thing that we do in the future is a graphic user interface, because it's the core idea of SoleXplorer. This is the pipeline, but it's not really interesting because I would like to do with you a real example of how to use SoleXplorer. This is not pseudocode, this is actual code on how to do an experiment with SoleXplorer. As you can see, I start loading the dataset. This dataset is a dataset taken from the dataset respiratory. That is recordings of breath of patient, healthy and with pulmonary diseases. And I choose a subcategory of patients healthy and with pneumonia. That is really hard to catch. As you can see, we start because we don't know if we can find something in this dataset. And this is the really beginning of the experiment. So I would like to try if there's something interesting. What I need with SoleXplorer, one function, only one function, symbolic analysis. And I give to this function the dataset and the vector of labels and the seed just to be reproducible. I don't know if it's English correct. Well, okay, we find something, we can move forward. We can then, because the default is a decision tree. This is the default for SoleXplorer, but we can choose a different model because maybe we can find a very good model that fit this kind of experiment. I try something. I try a model random forest that is a custom random forest algorithm that is specifically for time series analysis. And then I try XGBoost classifier. In this case, automatically, because XGBoost is not time series ready, automatically the dataset will be converted in a punctual dataset. So we can continue without setting anything. It takes the control of anything. Sorry. Then we can move further. We find that the XGBoost classifier is very, very, very interesting. And we try to setting some hyperparameters like resampling, tuning, balancing if needed. And we choose some measure performance to check it out. Now that we have a model, we can stop, but we have a couple of weapons, new weapons. So I try to extract some rules, and here you can see the rules that I have extracted from this data frame, and are very interesting. As a sound technician, I would say that V3 and V2 that are a portion of frequencies are very, very interesting. Then I would like to see if there are some associations between these rules that I found. And I start association model. association rules. And I see very, very, very interesting associations between the rules that I have extracted. Now, what I have in my hands is something that can be discussed with doctors, professionals, audio technicians, of course, and we can see if we have learned something from the experiment. Not only performance measure, but we have really something in our hands that can be understand, is human readable, and is something that maybe we can learn from this. For your curiosity, I have found that pneumonia hides around 300 and 400 Hertz, and is not a line in the spectrogram, but is some point. This is a digression. Then, for conclusion, as I say, the matter is that we go over the performance measures and we include rule extraction and rule associations that makes experiments more on human side, for my point of view. Thank you.
So much.
Good question, actually. Curious what kind of distance metrics you support. I saw Euclidean up there, but interested what other one you support. And then also the ability to do like multi-threaded association learning. If that's a factor you kind of already built in, or if that's coming, or thought about.
Yeah. Thank you for the question. Okay, for the first point, this is only one way to... You can use any distance function, but in the specific case of time series, I suggest to leverage the Euclidean distance normalized. Because if you use other distances such as time warping, well, the problem is that such distances may be defined also for intervals that are of different lengths. So the computation of support here becomes a problem. Support is simply the probability of a fact being true on a world. The problem is that all the worlds are suitable for computing the distance now. So, but you could also define your distance if it makes sense. For example, now we are thinking about the spatial scenario, so probably we will implement other distances or take them from other packages. For what regards the second question, well, currently we have implemented 3 algorithms, which both are multi-threaded. Okay, 2 of them are not so good in practice. We implemented them for because they are famous in the literature, and they are named a priori and eclat. The third one, the state-of-the-art, is called FP growth, and we provide a parallel implementation of it. Yeah.
Maybe you already said that, but doesn't this work for prediction? Can it be done instead of standard machine learning algorithm? Could I use those rules to do predictions? Like, I know that there are some algorithms for this, but I mean, in your case, we don't. I just want to ask this, and then there is another question.
Okay, very fast. Well, the purpose of modal association rules is mainly to describe. In fact, the hypothesis is that you are providing me a dataset where the label, well, it is I'm supposing to being describing only one gesture, for example. Okay, this is the scenario.